Hey guys, it's your boy here, Bomas, coming back to you with another epic math lesson. Today, it's your boy, Nuptial Failures. That's right, that's my Minecraft username. We are going to be doing some epic Minecraft applications for the math that we've been learning. So let's jump right into it. Alright, so I'm assuming most of you have played Minecraft before and know a thing or two about redstone, but if not, the idea is simple. Redstone is a device that carries current, and you can use it to activate contraptions, be it turning on a lamp, or you could activate a fence, or, a bunch of different things. It's a really useful mechanic of the game, and it really brings the game to life. So, what we're going to be doing today is looking at some of the math of one of these components. So one of the important components in redstone is a thing called a repeater. And the idea of a repeater is it allows you to extend your signal. So redstone normally only travels 15 blocks, but with a repeater, you can make it travel further. So if I lay out 15 blocks of redstone, all right, we got 15 blocks here. Turn that on, all right, the signal goes over here, right? But then if I try and go any further, the signal doesn't travel. So to extend it, the idea is you can use a repeater, and then the signal can go further. But a repeater has another interesting application, which is what we're going to be focused on. It can delay the pulse. So normally when I press this, you see there's a slight delay from when this turns on to when this turns on. And if I extend this delay, then you see that, oh, it was even more noticeable, right? So we can chain a bunch of repeaters together to really delay the pulse that goes through. And so the repeaters have either one tick of delay, and the units are called ticks. So one tick of delay, 2 ticks, 3 ticks, or 4 ticks. And so we can chain a bunch of them together. So this would be 4 plus 1 plus 1, or 6 ticks of delay in the signal. So then if I were to get this going, we see that our signal gets delayed by about 6 ticks here. All right, awesome. So that's the idea. And now what we can do is we can make clocks with these things. So let's say we want this light to turn on, but we want it to turn on and off and on and off over and over again. So what I can do for this is I can lay down a bunch of these repeaters in a circle. And there's a bunch of different ways to make clocks in this game, but this is one of the simplest clocks that you can make. So what you do is you send it a pulse, and then you turn the pulse off, and you see it just kind of goes in a circle now, right? The delay allows it to kind of not all be on at once, so we get a clock here. And so this clock is going to be firing at whatever the total number of ticks we have here is, right? So if I increase the length of some of these, the clock will fire at a slower pace, right? We see now it's going much slower than it was before. And so we're going to be experimenting with these clocks today and looking at the math of them. So let's now get into Exhibit A. So in Exhibit A, I have 2 redstone clocks here. So this one is going at a rate of 16 ticks, and this one is going at a rate of 10 ticks, and they are both hooked up to some note blocks here. So every time this triggers, it's going to play a sound. So what I can do is we see that they are now going, the sound is being fired every time the clock comes around, and they're going at different paces, right? So this one is firing every 16 ticks. This one is firing every 10 ticks here. So the idea is when are these going to actually sync up? If we watch, the notes will periodically sync up. See, it happened just there, right? So I want to know how frequently are they going to sync up. And to do this, we need lowest common multiple. Because what happens when they sync up? Well, that means the same multiple of these ticks going around and the same multiple of this tick going around that occurs when they fire at the same time. So to do this, we are going to find the lowest common multiple of 16 and 10. So I have their prime factorizations written out here. And so that means the lowest common multiple of these two is going to be, well, just make sure that we cover all their prime factorizations. So we covered 16 with the 4 2's, and we covered 10 with the 2 and this extra 5 we added. So when we multiply all this out, we are going to get 80. All right, so that means every 80 ticks, these are going to sync up. So if this one's occurring at 10 ticks, basically every 8 times this goes, they're going to sync up. And if this one's occurring at 16 ticks, every 5 times this goes, they're going to sync up, right? Because 5 times 16 is 80, and 10 times 8 is 80. So let's watch. All right, so they just synced up. All right, so let's wait for the next sync up. 1, 2, 3, 4, 5, 6, 7, 8, sync, right? See that? So this happened every 8 because it occurs 80 ticks. Now let's see if we can watch it for the 16. 1, 2, 3, 4, 5, 1. See, they synced up after 5. I kind of got screwed up on the counting, but you saw that that happened 5 there, and this happened 8, and they repeated after 80 ticks. All right, so that's that one done. Now let's go on to the next one here. The next example, we have this clock going at 18 ticks. This clock is going at 12 ticks. All right, so how often do they synchronize? Well, let's see here. We have 18 ticks. So 18, what is that? It's prime factorization. That is 2 times 3 times 3. And over here, we have the prime factorization of 12, which will be 2 times 2 times 3. All right, so the lowest common multiple of 18 and 12 then is going to have to be 2 times 2 times 3 times 3, since the 2 and the 3's are covered for 18 here. And for the 12, the 2 2's and the 1 3 are covered right here. So our lowest common multiple then is going to be 4 times 9, or 36. So every 36 ticks, this is going to repeat. So if for every 36 ticks, these get synchronized, we're going to see here that after 3 of these, right, because it's 12, 12 times 3 is 36. So every 3 of this one pulsing, we should get a synchronized. And here we have 18, and 18 times 2 is 36, so that means every 2 of these pulsing, we should get them synchronized. So let's count here. 1, 2, synchronized, right? So it was only every 2 for this one, and we expected that because that was the 18. And then over here, all right, let's count again. So 1, 2, 3, synchronized, right? So it's only every 3 that they synchronize. So 12 times 3 is 36, so we would expect that that gets us our synchronization. So our lowest common multiple is 36. That's how frequently they synchronize. Awesome. Let's go on to this last one here now. We have 3 different ones this time now, right? We got 6, we got 8, and we got 20. So they are going to be firing off 3 different note blocks here. All right, so we got our 3 different clocks here going at their own paces. And let's look at what all of their lowest common multiples are. So the first one we have is 6. So 6 can be written as 2 times 3. And then the next one was 8. 8 can be written as 2 times 2 times 2, right? Those are their prime factorizations. And 20 is 2 times 2 times 5. All right, so these are our prime factorizations. So when we look at the lowest common multiple of 6, 8, and 20, what are we going to get? We are going to get 2 times 2 times 2, that covers all of 8's, times 3, which will cover 6's, right? We already have the 2 covered, and then to cover the 20, we just need the 5. So when we multiply all this out, we are going to get 4 times 6, which is 24, times 5 is 120. So that means every 120 ticks, these are all going to synchronize up. All right, so for 120 ticks, that means every 20 of these, we're actually going to get a synchronization. So let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, synchronized. See, so every 20, this one repeated. Awesome. So now this is 8 ticks, 120. 8 goes into 120 15 times, so we should expect every 15 of these, we're going to get a sync. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, synchronized. See, every 15 is synchronized. And then for this last one, 20. So our synchronization rate is 120. So 20 goes into 126 times. So our synchronization rate should be every 6 of these, they will synchronize up. So let's find out. 1, 2, 3, 4, 5, 6, synchronized. See, so every 6 of these, they synchronize. So we see that 120 is the lowest common multiple of all these numbers. So once we get to that multiple of the numbers, they will be synchronized and they each kind of go at their own rate. So the application of this is it doesn't just have to be note blocks. Here, let's shut this off. It doesn't just have to be note blocks, right? All we need to do is just have 2 different events attached to 2 different clocks. And you want to know, okay, how often do these events line up with each other? Boom, you can just use lowest common multiple. As long as you know the ticks of all of the clocks that you're working with, you can use that to find the lowest common multiple. Well, I hope you guys absolutely gobbled up that spicy Maths application video. Thanks for joining me. I hope you loved it. And hey, maybe you just got a little better at math and Minecraft at the same time. But that's going to do it for me today. Signing off is Nuptial Failures, and I'm going to see you in some more epic application videos. Have a good one, stay groovy, and I'll see you in that next video.